Yeah, I think recording started. Yeah. Okay, so today I'll be mostly giving demonstration on this Maestro visualizer, and I call it as a molecular microscope because in this visualizer you can see all the biomolecules, protein, DNA, RNA, or a ligand in a very microscopic details or the atomistic details. And as I told, I'll be the sole contact for your any kind of doubts, and you can reach out to me. And this is my email ID. Okay. So before jumping to the Maestro, I'm just giving some background of what we are trying to achieve during this training session. And this is a video or is a molecular dynamics simulation that we ran. And you can see that this is one drug molecule that is coming, and when you take a drug molecule, it will come to a particular target, and it will goes and binds to the active site. So then this is actually happening in our body, that when you are taking a drug molecule, it goes to inside your body, inside your cell, and it particularly finds your target, and then it binds. But if you look very carefully, you can see that it is a multi-component system where you have one is the protein, another one is the ligand. Then there are like water molecules because in our body, 60 or 70% are water, and also there will be some ions or counter ions will be present. So you can see that this is a multi-component system, and due to this temperature, all are in fluctuating in nature. So the holy grail of drug design is that how to design a drug molecule that can suitably binds to this particular pocket of your receptor. And there are various techniques are there computationally. So those are like classified in two difference. One is the structure-based drug design, which means that you already have the structure of your receptor, that is the mainly the protein structure, either from crystal structure or you can do the homology modeling. And the structure based on like molecular dynamics, molecular docking, or free energy perturbation. And we'll be covering molecular dynamics, molecular docking in our training sessions. And there is also another method called ligand-based drug design, where you don't have any information about your target structure, that is the protein structure. Then you go for all this ligand-based technique, that is the QSR or biosynthetic replacement, R group replacement, pharmacophore modeling. All those techniques will be there, and probably we'll also cover some of the aspects of this ligand-based drug design. And student, if you have any question or any doubt, you can always ask me. So today, as I told, I'll be giving demonstration on the Maestro. So if you are using Windows, and then you can see that there will be a Maestro icon. It will be there, or you can search it from the panel. And you need to double click on this Maestro, and you can open it. This Maestro interface. And if you are using Linux, then if it is correctly installed, then you can open the command line or the terminal, and then you can just type a Maestro. Remember, the M is in small letter, and if it is not properly path is given, you can go to this the installation directory. Typically, it will be in the opt folder, opt Schrödinger in this folder, and from there you can also access this Maestro interface. Okay. Or if you are using Mac, then you need to just click the Maestro icon there. Okay. So now I'll go to the next step. So when you अगर आप open करते हो this Maestro interface, you will see this kind of interface, graphical user interface here, and I'll just explain one by one. So in the right corner top, that is called the selection toolbar, which means that you can access all the selection. Like if you want to access from some of the atoms or some part of the ligand, then you can access from here. You can see here there is a called P, which you can directly click, and you can get all the residues for the protein, then ligand, or the if there is a present of solvent, then you can access it from here. And the main window here, this is black color. We call this as a workspace. So whatever you work will be doing, it will be visualized in this workspace, this entire black space. And there are other sections are there, like in the top right corner, that is the job control status, where you can monitor your job. Then from here, you will get this is called the rendering options here. So you can render all your molecule in a different format, or you can color in a different ways in your molecule. And in the left hand panel, exactly this is called the workspace navigator. So this is called the workspace, the black region or black space called the workspace, and this is called the workspace navigator. Means that you can navigate what you want to achieve it here. You can make changes here, and you can direct what you want to do, and that you can visualize in your workspace. So that is why this section is called workspace and navigator. And मैं जब इसका demonstration दूंगा, then it will be much more clear that what I am trying to say. And you will see that it's very user friendly and very easy to use this Maestro interface. Okay, so there are other sections are there, like this. We call this structural hierarchy. So whichever it will be selected, it will show some of the structures what are there in this corresponding structure. Then we call this as a 2D overlay. So if you are importing a ligand, and if you see that there is a bound ligand or co-crystallized ligand, that will be seen in a 2D overlay. So all these sections are there, and I'll explain when I'll be demonstrating this in more details. Okay, so I'll go to the demonstration. So I'll just open my Maestro interface. Okay, so this is the Maestro icon here, and I'll just click it here, and then my Maestro interface, it will going to open. Okay, so this is the main Maestro interface. As I told, this is the selection toolbar, and this is the workspace. This is the workspace navigator, and there are different sections are there. So we'll cover one by one. Okay. Yeah. So first thing, what I will do is that I'll just try to create a molecule here and how to sketch a molecule, and then I'll explain in more details. So first thing what you always need to do is that always if you open any Maestro, you need to go to the file, and you need to change working directory. So whenever you are opening a Maestro interface, that time you need to go to the file and change working directory, which means that whichever work that you will be going to do, that will be saved in the corresponding folder. Okay, so I'll be creating a new folder. So I'll go to desktop, and I'll create a new folder. I'll give a name Maestro demonstration. And this will be my current working directory. So whatever work that I'll be doing, it will be saved there. So I don't need to search it again that for where I saved. And you can see also that there are different sections are there, or tab. So the first thing is file, then edit option, select option. All those options are there. So you can correlate with your like Microsoft Excel or Word file. It will be similar kind of thing like file, edit. So file means that You can import any file or you can open any file. So similarly, you can create a new project, open a new project, or you can import some of this structure. So all these tasks that you can do it from the file option. From the edit option, you can edit your molecule, whichever they are in the workspace. So gradually you can see all this option, and I'll explain one by one. So first thing, then I'll try to draw a molecule, and I'll draw a paracetamol molecule. So what I need to do, I need to go to the edit option. There is an option called 2D sketcher. So you need to click that 2D sketcher panel. So this panel will appear. So I'll tell again, you need to go to the edit, then 2D sketcher, and click that one. So now this editing panel will appear, and in the left hand panel you can see all these different atoms are there, and this is the entire periodic table. So whichever atom you want to draw, you can select it from the panel. And here also, like, different functional groups are there, different size of 6-member, 5-member rings are present. So depending on what you need, you can edit your ligand. So as I told, I'm going to draw a paracetamol molecule, and for the paracetamol molecule, we need a benzene ring. So I'll just click this option of the benzene ring, and I just place it here. Now you can see that your benzene molecule is created, and now we need to add some additional functional group for the paracetamol. Yeah, any question? Okay, so so this is like different bond. So for single bond, you need to click on this single bond, and you need to be very careful that from where you are joining your next atom. So if I place my atom, place my mouse in any of the atom, you can see that it will be highlighted in a gray circle. So which means that your atom will be attached from this link from here. So if I click here, a single bond will be created, and then I can add OH here, and then for paracetamol I will need to add another single bond on here, here. So like this. Okay, so and if you drawn by mistake, you can again go back by click. Like if I draw any mistake, then you can click back to your previous step like this. And if you go forward, then you can do like this. So I'll just draw again paracetamol here. So I need double bond here. So I click double bond, and I place oxygen. So this is my paracetamol molecule. So, and if I click this one, and if I click again any of the atom, it will form a double bond, but you can see that there is a mistake because carbon now has a 5 bonds. So now it appears as there is a error there. So you need to be careful, and you need to see that the valency is properly satisfied or not. So all those things you need to be very careful. So this is now I draw a paracetamol molecule. Now I want to set this molecule. So there is an option in below, like save as option. So I click this option, and I'll rename it as a paracetamol. And if I click OK, then you can see that your molecule will appear on the left hand in the workspace, and also in the workspace navigator by name paracetamol. And if you look carefully, I draw it in a 2D sketcher, but it automatically give the 3D version of the molecule. You can see that this is already 3D version. So you don't need to convert again like a 2D to 3D. This Maestro is very intelligent, so it will automatically convert your molecule from 2D to 3D. Okay. So now I'll just some trick I'm going to show using your mouse. So if I press only the right right key from the mouse and hold it, then you can translate in the XY direction. And if you press the left mouse, and then it will be selection. So I can select the entire
तो इसको
molecule.
चलाओ ना, पैरेलल में इसको चलाओ ना। हाँ
Yeah, any question or doubt?
No doubt. Please continue.
Okay. So, and if you hold your scroll button, and then you can actually rotate your molecule.
अरे नहीं हो साथ में कहाँ चल पाए, ऐसा करो आप क्या। हाँ ठीक है,
Okay.
ओके।
And if you just scroll your mouse, then scroll button, then you can actually zoom in and zoom out. Okay. So I'll again explain what I trying to say. If you press your right panel or right mouse, and you can translate in the XY direction or Z direction, the compound, and the right panel is this is selection, then you can select the either entire molecule or select only the particular atom by clicking. And mouse option, if you scroll down, it will zoom in and zoom out. So all these options are there, you can access to mouse. Now, this is I told, this is a selection panel. Now we can see that there is a symbol atom, which means that if you select any particular atom, it will only select the particular atom. But if I click here and go to the either residues or molecule, now M will be selected, and you can see that in my mouse, the yellow color N is appeared, and the pointer. And if I just click any of the atom, now the entire molecule will be selected. So I'll again explain. So here is a different option are there. Like if I select the atom, now my pointer will appear as an atom. So I just only select only particular atom here. But if I go back and I select the molecules here, and if I click any of the atom, then the entire molecule will be selected. Okay, so I'll just select the entire molecule. And now I'll go to style option here. As I told, this is a rendering option. So if I click it here, and these are there like different rendering option, like the tube representation or thin tube, then ball and stick. So if I click any of this one, you will see a different ball and stick representation mode. So I'll go back again and just click this as a CPK representation. So now you can see that it will be in a different rendering mode. And these options are for like coloring your atom. So if I go back and I select, you can specify any color that you want to choose and select that one, then your molecule will be colored in a different way. So this style option is for rendering, from where you can actually render your compound. And here, as I told, this is a 2D display, 2D overlay. So whichever you are showing here in that particular the ligand, it will be showing that this is my 2D display of the molecule. And below here, this panel, we call it as a status bar, which means that whatever molecules that are there or atom present in this workspace, all this information you will get it from the status bar panel. So like that, currently it is telling that there are like displayed 20 out of 20 atoms, which means that in this paracetamol there are 20 atoms, and the residue called as a UNK, and the name is showing paracetamol. And if I just hover my mouse in particular atom, it will also show that which atom that I am now. When currently it is showing I am on the oxygen atom from this status bar panel. Okay, so I'll just explain it again from the 2D sketches. So what I did is that I just so far what I did is that I go to the edit panel. I'll go to the 2D sketcher, and since I already draw it, it is appearing again. and in the 2D sketcher panel, you can draw your compound. So now I'll again just draw a new compound or do some changes here. So I just want to make some random changes. So I just click it here again, and I just press O and CH3. So this is my new paracetamol or substitute, different substitute paracetamol, and I want to save it as a new one, and I'll call it as a my design. Okay, so now again you can see that if I close it, this one, this again molecule will be appearing here. So this is my new design, and this is my original paracetamol molecule. Now I'm going to explain a very important concept from the workspace navigator. So as you can see, there is a workspace navigator, and it's called as an entry list. So whatever molecule or you're importing, it will be listed as an entry list or as a table format with their column, the row that is a 1 to 2, and the column like this in title like that. So in means that it is included. So if I click that circle, now this will be included in my workspace. But if I click this one, my new design will be included. So this is the one concept that if you click this particular include option, whichever circle it will be appearing, that will be showing in your workspace. And this blue color strip, that is called the selection mode, which means that now this my molecule is selected. So there are concept of inclusion and selection. So this panel, this column is called inclusion or included, and this is a selection column. So if I click that one, you can see that my paracetamol is included, but my design is now selected. So you need to be careful that if you are doing any kind of task which you are including or which you are selecting. So that is very important. Okay, so I'll again explain. So there are like two different concepts here. One is that inclusion and another is a selection. Selection is that whichever is highlighted in this blue color, and inclusion means that if I selected this circle, then particular molecule will be selected, and that will appear in your workspace navigator. Okay, so another is that below workspace navigator, there is a structural hierarchy. So as you can see that whichever is included, so if I include the first one, that will be in your current selection, and that will be in your structural hierarchy. If I select this one, then my design will be appearing in your structural hierarchy. Okay, so again that is comes with this inclusion. So if I select this my design compound, and it telling that it is a ligand, and if I click further below this triangle, and again it will tell that the residue or name is that UNK. And if I placing my mouse here, there is a also one style bar appear, and from here also you can render your molecule. Okay, so again I'll explain. So if I include this one, then this paracetamol molecule will be in your structural hierarchy. If I click it here, and again I can access all this rendering option from this structural hierarchy panel as well. Okay, so any question or doubt so far?
Hello, sir.
Sir?
Am I audible?
Yeah. Yes, yeah.
You have shown how to draw the structure. So, in a parallel way, can you show how to upload an HDF ligand also?
Yeah, sure. So that is I'm going to come. So I'll show some easy trick. Okay. So I'll go to just hold on. I'll just open I'll go to PubChem. Okay, and you can see my Google Chrome browser, right? PubChem. So I'll search paracetamol here. Can anybody tell that you can see this PubChem website or this my Google Chrome? Hello?
Yes, sir. We can see.
Okay, yeah. So this is a paracetamol molecule from the PubChem database. So you can go to any other database like ChemBin, and here you can see that different options will be there. Okay, and there is option for download coordinate. Okay, so you can download this as a SDF format. So for you, I'll just show you. I'll just download this paracetamol molecule. Okay, and other option is that you can copy this canonical smile. Okay, so I'll just copy this one canonical smile, and I'll go back to my Maestro, and I'll just go to edit to this sketcher. Okay, so I'll just delete. So this is a delete option here, and I'll just paste. So again, this if you paste this canonical smile, then it will come here, and you can again save it. Okay. So I'll again tell what I did. So I'm going to get another molecule here. There's another molecule for sitagliptin, which is useful for your diabetes. So I just go to sitagliptin molecule and I click it here, and I'll go to the canonical smile. I copy it canonical smile, and I go to edit to this sketcher. I'll erase this one and I'll paste it. So this is my sitagliptin molecule, and you can again save it and then save it as a like sitagliptin. So this is one way, and I'll just show that how since I downloaded this paracetamol, so I'll just we need to go to the file, import structure. Okay, so I downloaded in my download folder. So currently it is saying that I am at user my working directory, which is the desktop Maestro demonstration that is earlier I have created. So I'll go to my download option, download folder. I need to check what is the file name. It's structure 2D. Okay, so yeah, so I'll just type it here. Structure 2D compound. So this is my corresponding SDF file that I downloaded from the PubChem database. And if I open it, you can see that this is the structure.
It will automatically recognize SDF as a ligand and PDB as a protein, right?
Yes, yeah. Exactly.
Okay. Yeah. And we can upload multiple ligands at a time
Yeah.
while
Yeah. So you can. So currently it is a one SDF file, but if you are downloading like thousands or lakhs of compounds in a single SDF file, you can import, no problem. So
importing by selecting each file, or only selecting the folder itself is fine.
So I'll just give you one example here. Okay. Suppose I'm interested in some kinase target compound. Okay, which is a common target for cancer kinase inhibitors.
Okay.
Okay, so if I search it here, you can see that I got almost 349 hits. Okay, so what you can do, if you're interested, you can download all this by click this option.
Okay.
So you can download this as a SDF format. This one, so it will download as probably it will download as a zip file, and you need to extract that one. No, it downloaded as a SDF file. Okay. So all these 349 is in an SDF format. So
Okay.
I will go back and import structure there. So I will go import structure, and I'm already in download. So it is a PubChem compounds, this one, kinase inhibitor, and you can open it. So all this 349, you can see here, all these 349 will be incorporated in your Maestro.
Okay, sir. Understood. Thank you.
Yeah.
Excuse me, sir.
Yes.
Sir, I have a question. When we try to import multiple ligands, it's always shows, sir, it's a PubChem ID number. It never shows it's their common names or names what we have file.
Yeah. So that is the thing. So when you are incorporating, so these are all ID, right? PubChem ID. So this is the way it is there in the SDF format. So if I open any of the file, you can see. So I'm opening this opening text file. Just hold on. I'm just opening a text file. Yeah, so if you are downloading from the PubChem, you can see that there is a name like this. Okay, so you'll always see this name here. You will not see the common name there because that is the format they have defined. The common name, it will not be there. Okay, so like that, I just told you that I just copied this sitagliptin and I give it a name that this is a sitagliptin molecule or paracetamol molecule. Then the title will appear here. Otherwise, it will be there. This all these IDs that will be there in this corresponding title folder. So that is a yeah.
Okay, sir.
Okay. So what I covered so far is that I just explained few things in this Maestro interface. Then how to draw this molecule from the 2D sketcher. There is also like you can draw it in a 3D. So there is an option called build. Okay. So I'll give you one example or two example here. So if I click this build of panel here, so I'll click build and I'll go to the other edits. Okay. And you can build also like different kind of peptides or DNA sequences like this. So if I go to the build biopolymer from sequence, so there is option that will come either you can build peptide or a DNA RNA sequence. So I just for the time being I'll just build a peptide. So you need to give the name first or the title. So I'll create a like polyalanine system. So I'll just give name polyalanine. Okay, and I'll just give the sequence. So I just need to type the how many alanine you want in your peptide, and the shape that you can generate either extended alpha helix or seed, different kind of seed. So all those options are there to generate your corresponding peptide. Okay, so if I just select the I want to build an extended polyalanine chain, then I just selected this extended and I click that build option, and you can see that this your polyalanine chain will be created at once. Okay, and it will be named as a polyalanine. And the same way, I'll again explain. I'll go to the first. You need to go to the build, other edits, build biopolymer, and now this time I'm going to build a DNA sequence. So I'll just give a name just as a DNA sequence, and I need to define my AT or ATGC sequence. So I just give AT, okay, and it will corresponding select the corresponding complementary pair, and you want to select a B DNA or a DNA, that is a form of the helix. So if I am interested in bDNA, if I go and click the build option, and now you can see that your DNA will be built. Okay, so yeah, any question? Yeah.
Generally, build option we employ to build a protein, right?
No. So protein. So it is a build option. You can only build peptide and this kind of DNA. So protein you need to go for either crystal structure or PDB, or you can do some kind of homology modeling. So I'll next thing I'll explain the protein.
Okay.
Yeah. So remember, so there are there are many ways you can build your system. One is that first edit to this sketcher. There's a build option here where you can build different kind of biopolymers, or if you want to interested some kind of fragments, like if I am this is my paracetamol molecule. So I just tell you one thing that I was seeing this DNA molecule. Okay, so this is my DNA molecule, and if I click my paracetamol here or my design here, it will appear like here. But then if you click this option like the fit, then it will be fit to your corresponding panel. So I can explain. So if I click this include my DNA here and go back and select this, click this feed option, it will be fit to your panel, visualizing panel. So this is quite useful. So next thing, I'll now going to import some one of the protein, and as I told, there is a PDB database. So where all the crystal structure and NMR structure are there. So PDB database, and either you can download your protein. Like I am interested in my this protein, which is the always have a like 4-letter code. So if I click that one, you will get all the information from this PDB database, and you can download your file like the FASTA sequence, the linear sequence, or the PDB format, and you can save it to in your local machine or local computer, and you can import it from Maestro, like file, import structure, and open that PDB file. And but there is another option is here. So I go to file, I'll go to file, get PDB, and I can type this code, which is 2P33. And so it will directly, if you have internet connection, it will go to the PDB database and directly download in your interface. Okay. So other options are there, like if you know that your crystal structure has multiple chain, like A, B, C, D, but if you are interested particular chain A, then you can specify chain A. So it will only download your chain A of your protein. And if you are also interested in the biological unit, then you can click that option, and it will also download your biological unit. Okay, so I'll again explain it here. You need to go to the file, get PDB option, type your PDB code, and you can also download multiple PDB files. You need to give a comma separated, like another comma, and give another PDB code. Then it will also download your multiple PDB file at once. So for this now, I'll just download this protein and I'll click OK. So now you can see that now my pop-up window will appear that it imported PDB structure to P33 successfully, and it will be showing in your panel or the workspace. And again, I need to go to the feed option here to select my protein. Okay. So for downloading the protein, you need to go to the file and get PDB option here. So now what I'll do is that now for I'll do some kind of rendering of my protein. Okay. So for rendering the protein, we already have some preset option. So this is the preset panel. So if I click the apply default, so this is our default Maestro. So if I click that on apply default, you will get this kind of rendering, where you can see that it zoom out to your ligand, and these are all nearby residues which are interacting with the protein. Again, I can change to any of my rendering option. So there are different options are there. So if I go to the ligand side cartoon, so you can do that and you will get a different kind of rendering. Or I can go to the option like ligand side surface. So it will be build a surface of the protein, and you will get this kind of picture. Okay, so you need to play a little bit, then you will get all this kind of rendering options easily. Now, as I told, you can access all this. I'll just go and just. So when if you are doing any kind of surface rendering, so I did this ligand side surface. You can see that there is a ACE option will appear here in the workspace navigator, which means that this particular entry has a surface option here, which you can also like hide it. So if I hide it, you will go back to your previous rendering here. So again, if you click it here, sorry, you need to yeah. So if I click it here, again you will get back to your surface rendering option. So I'll hide it for the time being. So I'm now going to explain some of this select option here. So earlier I explained this atoms, molecules, while I explained ligand. Now I'm talking about this protein. So this P option is for like protein atom. So if I click P, all the protein atom will be selected. Okay, like you can see that all the protein atoms will be highlighted. And if I want to interest in the ligand, then only ligand will be selected. You can see that ligand will be selected. And again, if it's selected, then you can go to the rendering option, and again, you can do all those kind of rendering, particularly for the ligand. There is also ACE option, which means that solvent. So if there is any other water molecules or crystallized water molecules that you can select. So if I select, and I'll go back to rendering, and I'll just select this option. So now you can see that these are all your crystallized water molecule. Those are present in the crystal structure. So I'll just select a ligand, and so now it is selected all this oxygen of water. And if I click that option here, it will again disappear. So I option is for appearance or disappearance. So if I click it here, it will appear, and if I again click, it will disappear. Yeah. So any question or any doubt?
No, sir. Actually, one more thing. This is
Yeah.
not exactly related to this. So, is there any kind of docking? Like, can we do docking for ligand and ligand?
So ligand and ligand.
Yeah.
So what is the objective of your doing that? Because I'm the first time I'm hearing
Yeah.
the ligand.
Actually, I want to know the binding probability of an. Suppose there is a lead. It's an toxic element. So there is EDTA, which is lead complexing agent.
Yeah.
I want to see the EDTA in complexation with lead, how much potent that binding capacity and that score is. In the same way, I want to compare the phytochemicals in the same pattern of EDTA, how it is going to bind with lead, which are the responsible functional groups attaching to lead. When compared to EDTA, what is the scores of phytochemicals? How far
Yeah.
it binding with
Yeah.
lead?
So I don't think docking will help you. You need to go for molecular dynamics. Okay.
Okay.
So again, I'll cover that in this training session, and that time maybe we can we can take those kind of problem. Okay, and those are like very specific problem, and generally people do those kind of because of they want to do some kind of formulation, right? They want to see that what is a particular attachment and what kind of interaction is happening between your two different ligand compounds.
Yes, dear.
Yeah, yeah. So that is, and again the formulation again is a different I would say different thing. So there's a different workflow for that one in your Maestro. So entirely for formulation.
Okay, sir. Thank you.
Yeah. Okay, so as you can see that now, if I go to the preset option in apply default, you can see that all this name of the corresponding residues will appear, which are near to the 6 angstrom. But if you are not interested to seeing that one, what you can do is that I can just click this option here, which is these are like call it toggle button. So this is for the annotation tool. So if I click and unclick, all this naming will appear. And also like from here, from the toggle option here, you can change the background. Like I don't want to see a black background on the workspace, so you can either select this this white color, then it will automatically change your background. Okay, so from here, this toggle option, you can do all those changes. Okay. So again, so I was there in this quick select option, and you can also click. If I click from P, sorry, yeah. So if I click this option here, there's a three dot here. Okay, so there is a different ways also you can select a different atoms. Like I am interested only the backbone of the protein atoms. Then if I click that one, all the backbone atoms will be selected. Same thing if I am interested on the C alpha atoms, then the C alpha atoms will be selected. So all this, it will be selected now. So all these various things you can select from this option. Like if you are a protein-protein or protein-protein interface, antigen and antibody. So all those interfacial residues you can access or get information from this three dot selection button. Okay. And same way, like there is also like solvent or water, you can select from here also. If I'm interested only in the binding site and the ligand, if I click, then my ligand and only the residues near to the 5 angstrom, all that will be selected. And again, I can do the different rendering here. So now you can see that now all the ligand and the binding site residues will be in a different mode. Now again, I'll explain one thing from this structural hierarchy. So now my protein is included 2p33. Okay, and below you can see that there are different ligand is there, which is this ligand, which is a co-crystallized ligand. So if I click this one again, you can make changes. So this is my ligand, and for the protein, it has only the chain A, and you can access all these residues which are there. Okay, and if I select any particular residues here, it will be highlighted in your panel, and you can make changes also from here. So all these options you can do it from this, again, this structural hierarchy panel. Same way like the ligand. Okay, so any question or doubt so far?
No, sir. We can proceed for preparation now.
Yeah. So next step, I'll just explain one more thing here. There is a protein here, right? If you can right click, you can duplicate it, like or you can split it by molecules or chain. Okay. So next thing is that all the task option, or what about the task that we can perform? So all this will be there in the task button. So if I click it here, you can visualize by the browse option. So if I browse it, you can see that there is an applications and there is a task. So in the application, this is a glide, which is for docking, molecular docking. This one for molecular dynamic simulation, similar for like industry docking. So all these different applications are there, and also like different tasks. So if I click any particular thing like the glide, so you can see that there is a receptor grid generation, ligand docking. So all those options are there. Okay. So what I'll do next is that I'll just prepare the ligand, this co-crystallized ligand from the protein. So I'll just go to the select, right click, and split by into ligand and chain. If I do that one, then you can see that it will be splitted by ligand, water, and protein. Again, you can visualize this as this is your co-crystallized ligand, this is your protein, and if I select, this will be all your water molecules. Okay, so I'll just select this ligand here, and whenever you are downloading the protein or the crystal structure, because if it is excess structure, the hydrogen atoms will not be added because it doesn't have that much of resolution. And at the same time, it may also have some kind of problem with the valency. It is not maybe properly, valency is not satisfied. So for that reason, we need to prepare both protein and the ligand before proceeding any kind of molecular modeling experiment, maybe molecular docking or molecular dynamic simulations. So whenever you are working with any kind, or if you are working with this PubChem database or any kind of database, you downloaded some ligand file, you always need to prepare before proceeding to any kind of molecular modeling experiment. Okay. So next step, what I'll do ligand preparation, or we call it as a leak prep. And what it will be doing is that it will adjust, or it will see that the valency of the different atoms, and it will adjust the it will add the hydrogen atom in the ligand, and at the same time, if I define the pH, it will also generate some kind of ionic or ionization form of this ligand, if it's possible. Okay, so I just selected this ligand here for the leak prep. What I'll do, I'll go to browse option here, and one thing is that you can either search by, if you know the what kind of task you are going to doing, you can type it here. So for me, this is a leak prep that I'm interested. So I just click it here. So this leak prep panel will appear. Okay. So I'll again explain what I'm doing. So I'm typing this leak prep, which is for the ligand preparation. And you can see that there is also like a start mark here. Okay. So if I click it here, now it will be appear in your this panel. We will call it as a toolbar or favorite toolbar. So some of the tasks you can, if you are repeating, you can make it appear here. So you don't need to again go back to the task option every time. You can access directly from this here display. So again, I'm telling. So you need to click this star mark here. If I deselect or click it again, it will disappear. Yeah, it will disappear again. If I'm clicking back here, again it will appear here. So I just click it here for the leak prep, and this will be your leak prep panel. The first option is that use structure from. So I'll be using this co-crystallized ligand 2p3c, and I need to select either from workspace entry or the project table. So I'll just select this project table one, which is selected. So remember, this is the, if it is highlighted in a blue strip, that is selected. One other thing is that if you are downloaded some other database, you can also give the SDF file name here, and you can directly import the from here. So you need to go to the file option here, and you can browse it, and you can give the file name here. So I'm not selecting. So this my molecule will be selected 2p33. So there is also like filtering criteria. So for the time being, I'm not going to that one. Next time I'll do. And the other options is that the maximum ligand size. So the liquid will only can perform if the ligand size is less than or equal to 500 atoms. So if it is more than 500 atoms, this ligand is going to this liquid will going to fail. Okay. The next option is that OPLS force field. So while you are adding some hydrogen atoms or other thing, it will do minimization. And for the minimization, we are using this OPLS OPLS force field. For ionization, so there are like different options. So one is the do not charge. So if you know that you are already prepare your ligand, maybe that time you can select this option. So do not charge we meant to see neutral compound, or I'll recommend that you use this option here, generate possible state or ionization state for the particular pH range. Okay, so normally this is useful. Like if you know that whatever experiment that you are performing, if you know the corresponding pH or the pH range, then you can specify all those pH range from here. So normally by default, it is given like this, that pH plus minus 2. So it will go from 5 to 9, plus minus 2 to 7. So for the generation of this ionized different possible state, we are using this EPIC method, which is again very robust. So I'll recommend that if you have the license for this EPIC, then you can use this EPIC. Otherwise, if you don't have, you need to have a separate license for using EPIC. Otherwise, you can use ionizer. Okay. And these are the other options like that for the chirality or the stereoisomer. So if there is a possibility of any chirality, then you can enumerate all this stereoisomer. Or if you don't want to see any chiral, like if you want to retain the chirality, whichever like the input that you are given, in that case you can retain your chirality. Okay, so next thing is that they generate at most 30 per ligand, which is sufficient. So it will explore all the possibilities and it will give the top 32 different possible state of the ligand. Okay, so yeah,
Sir, can you
any
please
question?
come again with
Yeah, which point?
yeah, can you please come again with ionizer and epic classic difference
Yeah.
between those?
Yeah, so different. So ionizer is we call it a rule based. Okay, so rule based means that we already know we have some database and we already know that if it is this kind of a sp2 or sp3 carbon, what could be the possible pK of that atom or the nitrogen or the oxygen. Okay, so it's a rule based method, which is generally it usually performs well, but for much better performance, we always recommend that you need either select Epic Classic, which is a original implementation of the Epic method. And what it does is that it individually calculates the ionization state and the pK of all the atoms. So it is much more accurate. And if you select the Epic, it already also have included some kind of machine learning algorithm. Okay, so for accurate result, you need to go with this Epic and Epic Classic. So I can explain more it better in the next session. So it is using the Hammett and Taft equation, which is a kind of a thermodynamic equation by which it is generating the pK value of the ionizable atoms. Okay.
Yeah, fine, sir.
Yeah, so other thing that is that there are two options is that like add metal binding sites. So if you know that your protein or your receptor has some at the metal atom and the ligand is going to bind to the atom, so you need to that case you need to activate this option, and in that case you will see more more conformation of the or more new kind of structure of the ligand that will be particularly suitable for your metal binding process. So that is important. And if you don't want to do any kind of changes, you could retain the original state. Okay, so I'll just go and I'll just submit this job, and I'll go with this. I'll give a rename to leak prep 2 3 ligand. Okay, so I'll click the press run. So we'll see that it will say that submitting the job here. Okay, and job is started. And when job will be starting, there is a job monitor panel here, which is highlighted now in a green color, like some job is going on. And if I click that one, you will get this leak prep 2 in running, and you can also monitor. But yeah, again now this job is completed, and you will get a status like that your leak prep 2 pp3 is completed, and it will be showing here. So I'll go back to here and select here. So now you can see that it only finds one ligand. Okay, and also you can see that all the hydrogens are added properly for this particular pH. Okay, so I'll again, yeah, any question?
Yeah, so we have done the ligand preparation process for one ligand. So
Yeah.
how we can do for multiple ligands at a time? The preparation.
Yeah.
process.
So same thing, like I'll be selecting. So I'll just select these 3 compounds. Okay. So for the selection of these 3 or compound, you need to go first click on the paracetamol, then shift, and if I click the next one, so all will be selected at once. Okay.
Okay.
In the workspace navigator. Yeah.
The second row checkbox is there, na? It's not necessary to fill this checkbox. Only this.
No. Yeah. So this is for the inclusion. Okay. So if this is now paracetamol is showing here in the workspace.
Okay, fine.
And if I click this one, the next will be showing it here. So this is important that all these 3 compounds are selected.
Fine.
Okay.
Sir.
So if I selected this 3 one, I'll go to the task, leak prep, and if I click this one, so already now it will be 3 will be highlighted. Okay. So now you can prepare all these 3 compounds together, or you can give you an SDF file, and you can give the specific path of that one. Like if you are going for preparation of like thousands compound, then you need to go to the give the SDF file name, and then you can do the process, and it will give you the corresponding on these structures.
And output format will be in SDF or a Maestro format. Which one
so
will
that I will come. Yeah. So that is I'm going to show. So when this leak tape job will be completed, you will see that a new entry will appear in the panel, which is kind of a naming leak tape ligand.out. Okay, and this is a prepared ligand. Okay, now what I need to do, I need to go back to my corresponding working folder. Okay, which is like my working directory is file. So currently my working directory is that desktop Maestro demonstration. So I will go to that folder and I will see what happened. So I'll go back and I'll go back. So this is my Maestro folder, and this is a leak prep folder. It will be created. Okay, and you can see that this output file, it will be given by name leak prep 2 pp3 ligand out.mez. Okay, so this will be the output file name, which is a file format is MEGZ, which is a default option for Maestro. It is not an SDF, but it is a Maestro format.
Fine, sir. Fine.
Okay, but again, you can save it. So I selected this ligand. Okay, I want to export. So export this structure, and there you can actually export in a different file format like mol2 or PDB format or SDF format. So any kind of format that you are interested, you can specify. So I'll select that 2p and give a name 2pp33 ligand prep .hdf. So this will be my hdf output format. So now you can save it and it will be save it to your working folder. Okay.
Okay, sir.
Yeah. So other important thing that you can see it here. Currently, it is telling that I am in a Scratch project. Okay. So whatever I am doing, it is not saving to your working folder. So whatever task that you are doing, you need to save it in a project file. So I go to the again file, save project as. So it will be saved to your working directory or working folder. So I'll give my name. So I'll give my name to like a Maestro demonstration. So this will be my project name. Okay. And by default, the extension will be .prg, which is the extension of project, and I can save it. Okay. So now you can see that it will be changing to the Maestro demonstration.project. And like it is similar, like if you are working in a Microsoft Word, you need to save that document first, right? Then you can edit it. One good thing is that it is the autosave. So whatever task that we are doing it here, it will be autosave. So every time you don't need to save it again. Whatever task that you are doing or make changes here, it will be autosave. So whenever you complete it and close this Maestro, you can access this again from the project file. Okay. So today I think I am done. So I'll just again reiterate what I have done so far. Then I'll close this session and maybe next session I'll go the protein preparation and then docking. Okay, so yeah, any doubt? Then I'll again recap.
No, sir. We can continue.
Yeah. What I did so far is that this is the again Maestro interface, and I talked a little bit about this different options that are there in the Maestro, and this workspace navigator, workspace, concept of inclusion and selection, then how to do edit your structure in this 2D sketcher. Then there is a option of this 3D builder. Then you can build your some kind of biomolecules, polypeptide, DNA, RNA, all those things, and you can build it from here. Then I downloaded a protein from get PDB option here. And then I was doing some kind of experiments on ligand prep, then different rendering options here. And yeah, so this far I completed. Okay. And tomorrow, what I need to check with Bikash that आप लोग tomorrow अगर available हो तो then we can also schedule a call tomorrow or any suitable time. तो हम लोग फिर protein preparation and docking को we can discuss.
Yeah, of course, sir. We can
Okay.
schedule tomorrow.
Okay, tomorrow same time, right?
Yeah, same time.
Okay, so I'll share the meeting invite. Okay, so one thing is that there is an option workspace here. So if I click the clear workspace, so whatever you are doing it here, it will clear again, and you can again start from a new. So workspace, clear workspace, and if I close this one,
Sir,
so yeah,
upon clearing that workspace, all the settings also will be gone, or only the visibility of
no,
the.
no, only the workspace visibility it will be gone.
Okay,
Nothing
fine.
it will going to change. Yeah.
Okay, fine.
So I'll again what I'll do, I'll just close this Maestro again. So I'll just quit it again. Okay, I'll go back to my working directory. Okay. You can see that this project file will be created. Okay. Which is the Maestro project file. There is a link prep option here. So again, I can go back and open the Maestro, and then I can import the project file, and you can see that whatever that I have been doing so far, you can again access it. So file, now import open project. Okay, so I need to go to my directory, which is desktop, then Maestro demonstration. So this one, the project file. So if I open it, and you can see that whatever I have done so far, it will be there in the corresponding project file. So that is one of the advantage, that you don't need to save it many times. When you save it for once, then whatever task you are doing, it will be automatically saved in the project. Okay, so I'll stop here, and after this call, I'll share this video, the recording video, so that students, they can again go through and practice. And tomorrow again we'll meet, and we'll discuss about the protein preparation and the docking. Because
Yeah.
here, okay, right?
Okay. Thank you, sir, for
Yeah,
your
yeah. Okay.
information.
Yeah, and any student, they have any doubt, I have my email ID. So yeah,
Sir, it's my staff, not a student. I am also a staff.
okay, yeah,
Thank you, sir.
yeah,
Thank you.
okay, yeah. So bye guys. So we'll meet tomorrow again at the same time.
Okay, sir. Thank you.
Yeah. Okay, yeah, bye.